Okay, for this particular chapter, chapter 10, over the muscular system, you want to print off the muscle word list that's on chapter 10 resources that give the functions of the various muscles, because a lot of the questions that are coming from this chapter are going to be from that function of muscles list that you will find on chapter 10 resources. So function of muscles. There are over 600 muscles in the body, and they're all organs of the muscular system. And here are the functions. Movement. Muscles use bones as levers to move various parts of the body and the body itself from place to place. Stability. Helps to maintain posture by eliminating unnecessary movements. Communication. You use muscles for speech. Control of body openings and passageways, like sphincter muscles. And heat production. Shivering produces movements that will generate some heat. This is the organizational plan of a muscle. So each muscle is a discrete organ, and it's composed of muscle tissue, blood vessels, nerve fibers, and connective tissue. So each muscle cell is called a muscle fiber. There's your myofibrils, and it has the sarcolemma on top. And then there's a very thin layer of connective tissue that surrounds each individual muscle fiber, and that is called the endomysium. Now, these cells with their endomysium bundled in a group, these groups are called fascicles. And a muscle fascicle has around it something called the paramysium. Now, the paramysium is something you can see if you have steak. You'll see this white marbleization pattern that runs through the meat. And so this is visible, and it softens up the meat by breaking apart the dense protein fibers. So this is what you would call the paramysium around each of these bundles, which is called a fascicle. Then you have all the fascicles and their paramysiums joined together, and the entire muscle is covered by something called the epimysium. Now, the epimysium is dense, fibrous, dense connective tissue, but it's dense regular. So all the collagen fibers are going in one direction, and the muscle tapers at the end into just dense regular connective tissue, which we call a tendon, and that attaches the muscle itself to the bone. So dense regular connective tissue is what makes up the epimysium. So skeletal muscle attachments. Now, muscles attach in two places. The origin is on the movable bone, and the insertion rather is on the movable bone, and the origin is on the immovable or less movable bones. Now, there are types of attachments. The muscle can be directly attached to the bone itself by way of the epimysium fused directly onto the periosteum of the bone, or perichondrium of the cartilage. It can be fused onto that too. Most of your muscles attach by an indirect attachment, and this is by the rope-like tendon that attaches the muscle to the bone, or it could be a broad sheet of tendon, which is called an aponeurosis. These are patterns of fascicular arrangement. So when you look at muscles, you can see this little banding pattern. People that bodybuild and they lose a lot of their fat for competition, you can actually see the bands of the muscle, the fascicles. So those fascicles have an arrangement. And there's several different ways that you can name the muscles by this arrangement of the fascicles. So convergent muscles are where the fascicles converge from a broad origin and they narrow into a single tendon insertion. For instance, the pectoralis major is one muscle that is a convergent muscle. Circular is where you have a ring of muscle, and when the muscle contracts, it closes the opening. So fascicles are arranged in concentric rings, and sphincters operate this way. The orbicularis oculi, or oris, the orbicularis oculi is the muscle that encircles the eye. It's the winking and the blinking muscle. And the orbicularis oris encircles the lips, and that's your kissing muscle. So those are circular muscles. Fusiform is a spindle-shaped muscle. It's kind of fat in the middle and it tapers at the ends. So the bicep brachii is an example of a fusiform muscle. Parallel is more strap-like. And the sartorius, which is the longest muscle in the body, crosses over the hip joint and over the knee joint. That's an example of a parallel muscle. Now, pennate, the word pennate means feather-like. And these are short fascicles that attach obliquely to a central tendon running the length of the muscle. So you can have multipennate, where you have multiple bundles of fascicles, and that's the deltoid, which is the superficial muscle of the shoulder. And then you have bipennate, the rectus femoris, and that one is part of the quadricep group. And then you have the unipennate, which is like a half a feather, and that one you find in the lower leg and in the forearm. An example of that is the extensor digitorum longus, which extends the fingers. Muscles can be classified by how they function. So there's 4 different types of muscles by function. One's called the prime mover, and another name for the prime mover is the agonist. And the agonist is the one that actually performs the major force for a specific movement. Synergists, they add to the force to a movement and reduce undesirable or unnecessary movement. Say, for instance, the prime mover of forearm flexion is the bicep brachii, and underneath it is a muscle called the brachialis. So the bicep brachii is the prime mover. The synergist would be the brachialis, which is underneath it. Antagonists are muscles that oppose or reverse a particular movement. So when you're flexing the forearm, you're stretching the antagonist, which is the tricep brachii, which is located on the posterior surface of the upper arm. And so when you're extending the forearm, you're contracting that tricep brachii and extending the bicep brachii. A lot of your muscles work in pairs, and depending upon which movement you're performing will determine which one's the agonist and which one's the antagonist. Fixators stabilize, so they are muscles that immobilize a bone or a muscle's origin. So if you're flexing the forearm, then muscles that will stabilize the shoulder would be your fixators. There's different ways to name skeletal muscles. You can name them by their location. So like frontalis, which is on top of the frontal bone in the forehead region. Occipitalis, temporalis, associated in its name for the location. And remember, we do have cranial bones that have those names, so that's where the muscle is located. Muscle shape, deltoid, because it's shaped like a triangle. Sometimes if you have muscles in a group or more than one, you might call the larger one the maximus, the minimus the smallest. Sometimes if there's 3, medius is intermediate. You could have longus for long, brevis for short. So these are just different ways you can name muscles. Direction of muscle fibers or fascicles. Rectus means they're running straight up and down along the long axis of the body. Transversus is at right angles or perpendicular to the long axis. And oblique, the fibers run at angles to imaginary defined axis. Usually we're talking about the long axis of the body. You can also name them by their number of origins. Bicep, 2 origins. Tricep, 3 origins. And we already talked about the bicep brachii, tricep brachii. Location of attachments, named according to the point of origin and insertion. We have a muscle that's called the sternocleidomastoid. Sternocleido, the origin is on the sternum and on the clavicle. Mastoid, it inserts on the mastoid process of the temporal bone, so that's where the name sternocleidomastoid comes from. You can also name a muscle for its action. Name for action that they produce, like if they're a flexor or an extensor. And several criteria can be combined. For example, extensor, carpi, radialis, longus. It extends the carpi, the wrist bone, extends the wrist, and it's on the radialis side, on the back of the forearm, on the lateral aspect, and it's long. So lever systems. Lever systems are ways that muscles, remember we said muscles use bones as levers, so there are different ways that muscles can be performed based on the type of lever that's involved. So a lever is just a long bar. And the fulcrum is the pivot point. So this green thing is the pivot point, that's the fulcrum. The load is the gray piece here. And then this little rectangle, that's your effort, that's in red. So an example of a first-class lever where the fulcrum's in the middle is a seesaw, where you have one person here, and the balance point's in the middle. Scissors is the same type of thing. Fulcrum, again, is in the middle. We don't have a lot of examples in the body of a first-class lever, but when you think about the relationship between the dens of the axis, the little pivot point in the head, the bottom of the skull, then that's your pivot point, the dens of the axis. The weight of the head is in the front, and to extend the head, the effort comes from the back. So the superior aspect of the trapezius and the splenius capitis, those two muscles together can extend the head and lift the load. So that is an example of a first-class lever. If you just remember seesaw and scissors, those are really good examples of first-class levers. Second class, now your fulcrum's on the end, your load's in the middle, and your effort comes from the other end, like a wheelbarrow. And if you're doing calf raises, that's a good example of a second-class lever. The effort is coming from the muscles in the back of the leg, the lower leg. The load is in front of that, it's in the middle, and the pivot point of the fulcrum is around the ball of the foot and the toes. So wheelbarrow is an example of a second-class lever. Third-class lever is where you have the fulcrum on one end, the load's over here, and the effort's coming from the middle. Most of your muscles operate under third-class lever systems, like lifting a weight, bending the forearm. There's your load there. The elbow is the fulcrum or the pivot point, and your effort is coming in front of that pivot point. So it's very much like a wheelbarrow. And like I said, most of your muscles operate under third-class lever systems. So major skeletal muscles of the body. There are over 600 in the body. They're grouped by function and location. And you can get a lot of information from muscles by looking at a picture and by its name. You can get the shape, you can get the location relative to other muscles, origin and insertion. Usually there's a joint in between the origin and insertion. The actions, the insertion moves towards the origin. And a lot of times the nerve that's associated with the muscle is similar in name and is also important because in order for muscles to work, there has to be a nerve connected. Now, this is a picture of the superficial muscles of the body. Now, what you need to do is follow along with your muscle word list and check off the ones that I go over because those are going to be possible test questions as far as function goes. So the intercostals here, those are the muscles in between the ribs, and they're involved with respiratory movement along with the diaphragm. Okay, so that's the first one. The back picture here shows you an overall view of all the different muscles that are associated with the back part of the body, and we'll be going over the ones that are important as we go. And we're going to start with the head, muscles of the face and neck. So we have this muscle that's, most of these I've tried to colorize in a different color than black, so they stand right out. So the orbicularis oculi, that's on your list. That muscle is the winking and the blinking muscle. Okay, it encircles the eye. Then you have the zygomaticus, that is also on your list. That one's called the smiling muscles because it lifts the corners of the mouth and enables you to smile. The buccinator, it makes up a lot of the cheek. And you can see it here. It's kind of embedded in another muscle. But what it does is when it contracts, it brings the cheeks inward, so it simulates that sucking action. So that's the buccinator, or called the sucking muscle. The orbicularis oris, also on your list. What that does, that's a circular muscle that purses the lips, and it's called the kissing muscle for that reason. The platysma is a muscle that's located on the anterior surface of the neck, and when you contract that muscle, it gives you that look of horror. So you should try that out. I don't usually do this one in class because my neck is wrinkly as it is, and I don't like the way it makes me look. So that's platysma, look of horror. Now you do have this huge sheet. Remember I was talking about an aponeurosia being a sheet of muscle. Well, the Gallia aponeurosis is the sheet of tendon that connects two muscles together. The one that's in the front of the head is called the frontalis. And the frontalis is also on your list, and that one will make you wrinkle the forehead when it contracts, and you can raise the eyebrows. The occipitalis is in the back, and then on the side you have temporalis. And I'm going to leave those for another picture. There's the temporalis. And the temporalis is attached to the choroid process of the mandible, and when that contracts, it makes the jaw close. So temporalis is on your list, and that is for jaw closure along with the masseter. So the masseter is on the list too. That one is attached to the zygomatic process, and it's also underneath the mandible. So when that one contracts along with the temporalis, it closes the jaw. There's a good look at the buccinator muscle right there. Pterygoids offer side-to-side movement of the jaw, and here the masseter is cut away. These are not on your list, but I just wanted to show you. They're part of the muscles, temporalis and masseter, that are involved with chewing. Masseters are up, masseter temporalis up and down, pterygoids side to side. Okay, there are some muscles that are involved with movements of the back and extension of the back, the erector spinae. And this one is not on the list, but I put it there if you're going into OTA or PTA. These are muscles that you're probably going to have to know in great detail. And the erector spinae group is made up of a group of three: the iliocostalis, longissimus, and spinalis for extension of the back. Muscles of respiration. We mentioned intercostals. There's external intercostals. They're more superficial muscles. They elevate the ribs for inspiration. The internal intercostals are deeper muscles. They aid in forced expiration. The diaphragm is the most important of the respiratory muscles, and this is on your list. It's a partition between the thoracic and abdominal cavities. It is the most important muscle in inspiration, and it's innervated by the phrenic nerve. This is the abdominal group of muscles that make up the abdominal wall. All of these are on your list. You have the transversus abdominis, which is the deepest of the muscle. It compresses the ribs and viscera, allowing thoracic and pelvic stability. And the muscle fibers, you can see the fascicles run in a transverse arrangement, so perpendicular to the long axis of the body. Then you have the obliques. You have the internal and external oblique muscles. And those are on your list. There's external oblique, compression or twisting the abdomen, internal oblique, abdomen compression, but they all do the same thing. And then you have the superficial erectus abdominis, and that's the major compressor of the abdomen. If you're doing sit-ups, that's the muscle that you're actually using. Muscles of the pelvic floor. So the pelvic floor, pelvic diaphragm, is composed of two paired muscles, the levator ani and the coccygeus. Now, I did not put these on the list, but I just wanted you to be aware of them, both innervated by sacral nerves. And what the pelvic diaphragm is, it seals the inferior outlet of the pelvis, supports the pelvic organs, lifts the pelvic floor to help release feces and resist increased intra-abdominal pressure. So here's a look at the pelvic girdle. There's that diaphragm, and you can see the coccygeus here, and the levator ani makes up just about all of that floor. Okay, back to more muscles that are on our list. The sternocleidomastoid. That muscle is involved in head flexion. Deltoid, which is this large muscle that makes up most of the shoulder. Since it has a multipennate arrangement, you can get multiple movements from this muscle depending on which groups you contract. So you can actually abduct the arm, you can flex the arm, bring the arm forward, or you can bring the arm back by using the deltoid. Pectoralis major on your list and minor, they work together. You can see the minor over here. But what they do is they're involved in hugging and climbing and bringing the arm closer to the chest, also involved in push-ups. So pectoralis major involved in hugging and climbing. Bicep brachii, also on the list. That's the major prime mover of forearm flexion. Serratus anterior. Subclavius is actually in red, but it's not on the list, so don't worry about that one. Serratus anterior, the way that it attaches, it starts at the ribs and then it attaches to the scapula. What it can do is it can actually bring the arm up, and it's responsible for producing that movement that you see boxers perform when they're giving somebody an uppercut. So we call it the boxer's muscle for that reason. Okay, some more muscles. Now we're talking about the back, and you can see the trapezius, very big superficial muscle of the back. The upper part goes into the head, so it's involved with head extension, and then fibers wrap around the spine of the scapula. So depending upon which fibers that you contract, you can elevate the scapula, you can move the scapula more medially, you can depress the scapula. So a lot of movements of the shoulder involved with the trapezius. So assist in head extension and movements of the scapula. Rhomboids, together as a group, and you can see them, these are deep, these are superficial. These muscles, by being attached to the medial surface of the scapula and then to the vertebrae, when they contract, they pull the scapula closer together, which we call squaring the shoulders, bringing the shoulders back. So squaring of the shoulders, rhomboids. We already talked about the deltoid, what it does. Latissimus dorsi, it originates on the vertebrae all the way down to the lumbar and into the sacrum and attaches to the humerus. And when this muscle contracts, it is a major adductor. So when you talk about the machine that you do the lat pull, that's for the latissimus dorsi. Infraspinatus is involved with depressing the shoulder blades. You can see it right there. It's under the spine. And the rotator cuff muscles, they act as synergists and fixators. They originate on the scapula and they reinforce the shoulder capsule and prevent dislocation. So you have the supraspinatus, the infraspinatus, the teres minor, and you have the subscapularis. And I did not put all these on there. I only put the infraspinatus on there. But it's good to know that these four make up that rotator cuff group. So you can see the infraspinatus there, and if you look around at different pictures, supraspinatus is there. You can find them all. Tricep brachii, most superficial muscle of the back part of the brachium, the upper arm, and that muscle is responsible for lower arm extension. So tricep brachii, and that one is on the notes, or it's on the list. There's your bicep brachii, underneath it, brachialis, that's on the list. That's a synergist that aids the bicep brachii. And the brachioradialis, it's involved with lower and upper arm movement, and it stabilizes the arm when you're using when you're doing exercise that you are using the wrist quite a bit. So tennis players holding the racket and swinging the racket, and overuse can cause tennis elbow. So tennis elbow is an irritation of the brachioradialis. So there's muscles of the forearm, the flexor carpi radialis, flexor carpi ulnaris, extensor carpi radialis, and extensor carpi ulnaris. These two are on the back of the forearm, and these two are on the back of the forearm, these two are on the front. So what this one does, the flexor carpi radialis, it flexes the wrist, and it causes lateral flexion of the wrist because it's on the lateral side. Flexor carpi ulnaris, it's on the medial side, so it flexes the wrist and causes medial flexion. The extensor carpi radialis on the back of the arm now, on the lateral side, extends the wrist and lateral flexion, and then this being on the medial side of the back of the forearm, extensor carpi ulnaris extends the wrist and medial flexion. Muscles crossing the hip and the knee joint, anterior compartment, the front, flexes the femur and extends the knee. Posterior compartment extends the thigh and flexes the leg. And the medial compartment adducts the thigh. So here's your gluteus medius and your gluteus maximus. Now let's go to gluteus maximus because that is on your list. The gluteus maximus is involved in leg extension. So it's a powerful leg extensor at the hip. The gluteus medius, because the fibers are running up and down, that one is a leg abductor. And then these three make up the hamstring group. So you have the bicep femoris right here. And then you have the semitendinosus and the semimembranosus. So all those three make up the hamstring group. They're all on the notes. So these are involved in, let's see if I can find them here, bicep femoris, major muscle of lower leg flexion. And then you have the semitendinosus and the semimembranosus. They work with the bicep, part of the hamstring group, do the same thing. Okay, so now we go to the anterior view of the leg, and these aren't colorized, but see this one right here, the gracilis? That one works in conjunction with these other muscles that are called adductors. They bring the leg in, adduction. But I only put the gracilis on the list because that's the most superficial. So it's adduction. Also, there are other adductors. We have a muscle that's called the pectineus. There's the pectineus right there. And that one is involved in flexion of the thigh. It works in conjunction with the iliopsoas, and also these are involved with taking a bow. Quadricep group. So you have the quadricep femoris, the rectus femoris, vastus lateralis, and vastus medialis. This group is the most powerful group of muscles in the entire body. And the quadricep group and rectus femoris is what's on the list instead of quadricep. Rectus femoris, major leg flexor. Let's see here. Okay, let's go vastus lateralis, vastus intermedius, vastus medialis. So when you're contracting this quadricep group, you're actually extending the lower leg. And I think that's all. That's all on that picture. Okay. Tibialis anterior. That's on the list. It's involved with dorsiflexion of the foot and inversion of the foot. It's located on the lateral aspect of the anterior surface of the leg, and it inserts under the foot, so movements of the foot, like inversion and bringing the foot up dorsiflexion. On the back, you have the most superficial of the lower leg is called the gastrocnemius. Gastrocnemius is involved with plantar flexion, and it works in conjunction with the muscle that underlies it. It's called the soleus. Now the soleus is cut here to show more deep muscles, but the soleus and gastrocnemius work together. Soleus is more of an aerobic muscle, important in long distance activities. And the one that we didn't mention was the sartorius. Now the sartorius is the longest muscle of the body, because what it does is it originates on the iliac crest, the anterior iliac crest, crosses over the hip joint, and then inserts on the medial surface of the tibia. So it's a long strap-like muscle, and it affects both the knee joint and the hip joint, so it enables you to cross one leg over the other. So that's the sartorius.